Hello, everyone. My name is Chad Jennings, and I'm the Global Head of Customer Voice and Product Experience for IBM Software. And today we are digging into how teams are shipping with AI. And with me is Tobias Kulvik. He's an AI architect at Frontkom. Tobias, great to have you. Thanks for joining.
Yeah, thanks, Chad. Yeah, my name is Tobias Kulvik. I'm an AI architect and Frontkom consultant. And yeah, my role is to be the solutions architect in projects where AI plays a key part. It can be a bit hard to do. The latest MIT report shows that 95% of all Gen AI pilots fail to reach production. So that's where my focus is on these days, is to build AI systems that actually ship.
That makes total sense. And with people doing, like, one of the things that inflates that number, why it's so high, is folks are doing proofs of concept with AI all the time. So there's a bit of experimentation tied up in that stat, but yeah, it makes complete sense. We got to focus on use cases to make sure things actually get out. Can you tell us a little bit about Frontcom, please? I don't think many of the viewers will know.
Yeah, so Frontkom's a digital innovation partner and digital agency that combines strategy, AI, design, and software engineering. And we're based in Norway, but we have offices in Poland and Portugal as well.
As we were prepping this, you told me a little bit about the platform that Frontcom has created. So this is a technical platform that allows you to, basically it's a starting off point when you're building for different clients. Can you tell me a little bit about the platform, please?
Yeah, so we decided that from both a business and a time to market standpoint, we wanted a common foundation for our Gen AI solutions. And for this, we used a few IBM tools and technologies.
And can you tell us a little bit about the typical customers that Frontcom has?
Yeah, so Frontcom works with both educational customers and organizations like big universities. We also work with commercial for-profit organizations and a lot for non-profit organizations. But the focus today will be working with a transport assistant for Reis Nordland.
I love it. Anything with maps is fun. As we transition, we'll talk about the use case, and I think the photo that you've got's got some really good context for people's brains here. So, as you bring that up, can you tell us a little bit about the use case that Reis Nordland asked you to help them with?
Yeah, so Reis Nordland, they are the regional public transport provider for Nordland County in Norway, which means they drive all the buses, the ferries, speedboats, and help you get from A to B. The goal for this conversational assistant was to offload their customer support employees by making travel information faster, smarter, and available 24/7 through a conversational agent. Their biggest pain point was basically that they had this very high repetitive support ticket volume, which they felt that they could resolve easier and faster with an AI agent.
Right, thus freeing up their support folks to dig into the more meaty things as opposed to the churning
Yeah.
one. Right. So, like, building on the use
Yeah.
case, like this is what the user sees.
Yeah, this is the result basically. It's a chatbot where users can ask all the different, like the typical customer service questions, but you can also ask a more dynamic questions like, when's my bus arriving to this stop? Or I want to travel from Bodø to Narvik tomorrow after lunch. And you'll have these dynamic cards and trips and routes that will show.
And having the user interface, I think, helps people understand exactly what you're providing to, both your customer, Reis Nordland, and what they're providing to their end users. Can you tell us a bit what was the primary technical challenge then?
And the technical challenge were what we were talking about now. We have to merge live data, which means routes, timetables, the current traffic conditions and such, with structured data, policies, FAQs, web sources, and internal documentation. We also had to deliver on a few requirements, like support for multiple languages, and the most important part, low hallucinations and factual grounding in the answers. So yeah, the outcome would be a solution that's conversational for users and controllable for operators.
You've essentially got two sets of customers for this single app. You've got your own customer who's got to manage the infrastructure, or sorry, the app as well, and you've got the end users. So you've got two very different user groups. To serve both of these, what were some of the design goals that you articulated as you got working?
There are different types of goals here, but for the platform, we wanted a reusable architecture that we can use across different clients that enables us to have conversational assistance, smarter search and knowledge retrieval and stuff like this. There's also quite a few constraints here. We wanted as the AI landscape is moving so fast, time to market is really important. Things are improving and changing every week, so we wanted a component-based design where we can swap out tech as it evolves. We also found that for the agent flows themselves, a low-code, no-code solution could work well to allow other people with other skills to also contribute to this development.
All right, well, that's quite a long list of, both technical and business and user stakeholder requirements. Can you show us the architecture that solved all those different points?
Yeah, so the entry point to our platform, there's two different entry points. We have the widget. In this case, it's a chat widget where that's placed on the user's landing page. This is where the end users use our platform. And then we have the Race Nordland administrators that use a dashboard. This is a Next.js application hosted in Vercel, connected to a Supabase database. Then there's also the component that actually generates these responses and handles all the agent logic. In this case, it's the IBM low-code, no-code tool called Langflow. It's hosted in Frontkom platform as a service on Kubernetes, on AWS, with horizontal scaling and with Fastly as a CDN. And Langflow also needs a database. For this, we're using an IBM Cloud Postgres database.
Okay, so you can see the different stakeholders here, right? There's end user way out to the left. On the landing page, they're also interacting with the chat widget, but then you've got the Race Nordland folks who are administering things, looking at the dashboard, and then looks like Langflow is powering the whole thing.
Yeah, Langflow is powering these agents. We can actually look a bit more into that now, I think.
Oh yeah, please, good idea.
This is a simplified architecture of these agent flows. And the basics are that the agent is in the center of everything, this agent component, and it takes different components to work. One of these is the input prompt. Here we take different inputs, like the user's prompt and a semantic vector search, like RAG. And then we also fetch some metadata to make this prompt. We fetch the latest system instructions from the database, and we connect this to the agent. But we also need, like you see in the diagram, a language model. In this case, we ended up using the Gemini 2.5 Flash model, but that's the result of loads of testing. So that's one of the things we recommend, is that the best way to find the best fitting model is actually just by testing. Try 5 to 10 different models with the client, often is smart, and figure out what works best in your price range.
That makes sense. And I think because of the modular design here, if you find that another model, like if you repeat that testing process in 6 months and you find that it's actually a different model that is optimal for there's a new release or whatnot, that you can seamlessly swap it out without affecting the experience of the end user. We need to power this agent with some of the tools and some of the knowledge that comes from the stuff that's over on the right-hand side. Let's get into that one next.
So as you can see here, there are loads of different tools that the agent can use. And these are the connection between the agent and the different APIs and information that are related to the public transport stuff, like timetables and routes and buses and stuff. Let's look at Plan Trip. This tool enables the agent to input a from place, a to place, and a departure time. And the tool will respond with a suggested trip, or actually several suggested trips, as well as like a UI payload. The reason we do this is that we have something called a trip card. It's a way we format these responses, which our UI handles, parses, and renders as these cards we looked at earlier. The point is, when we format and make these UI payloads in the tool and respond to the agent with them, we reduce the hallucinations, so we really don't ever see that.
One of the most important functions you've actually, which is like, hey, the customer wants to go from here to here, you've offloaded that to, your customer's actual own NPI, and you don't rely on the agent for it. And then even by bringing those UI elements in, you've really bypassed the agent for this particular thing.
We also have a tool that's called Search for Place. It basically enables the agent to have up-to-date local information about Nordland. So you can ask I want to go to the library in Bodø, and it will query the Google Places API along with the Entude API to find these places.
Yeah, and that then you can just like, add like a much more natural language search to things as opposed to needing to know the exact right name. Yeah, that's
Yeah.
an excellent addition to deliver a wider variety of capability to the end user. And I'm sure we could go through each of these, right? Because essentially, each of these new tools and new API connections is some new capability here. But let's pivot now and talk about what lessons learned you gleaned from your experience here.
One of the most important ones is that we want to keep the context window as small as possible. The smaller the context into these large language models, the sharper the responses will be. The output quality mirrors the quality of the input. So
Mhm.
when you're talking to these models, the only thing you can actually control usually is this input tokens. So let's spend some time and get that right.
That's a common misconception that really you can just like pour your problem into this black box that says LLM on the outside and then like answers will flow. And that's actually true, but you might get wrong answers as well. And so, your wisdom here, like to tighten the inputs so that you tighten the accuracy of the outputs, I think is really important.
And there are several ways to do this, but easy one to use is just to split these larger tasks into smaller steps or separate calls. That's very relevant for like data analysis and stuff, but it's also relevant for conversational agents and flows.
Yeah, and another solution to do that was to like for stuff that you really wanted to have be like critically important, you could even offload that from the agent and use an API to serve like the routes and the cards that you bring in.
Another thing we found that's really valuable is that this modular architecture we were discussing earlier, it
Mhm.
matters. Uh, just while we're developing this, new models was introduced, new different components and APIs change and stuff. So having a modular architecture is really valuable, saves us a lot of time, and allows for this rapid experimentation that we find valuable.
Yeah, complete agreement there. I think most people will agree, but the specific why of being able to swap in new rapidly developed, new launches from your vendors like us is really important. Okay, any other ones?
Yeah, maybe the most important one is that we want to make any Gen AI solution as little of a black box as possible. This means we have to make our solutions debuggable, store the context information and the tokens, store tool usage, and stuff like this. So yeah, that we've found to be very valuable. Also, version control on your knowledge base, being able to go back in time and look at the actual version of these chunks that was used to generate an answer. Uh, it saves a lot of time and headaches.
All right, well, let's wrap up by what you see looking forward. You've already had some great success in the first weeks of launch with the support tickets that you mentioned.
Yeah.
You've got a happy customer here. But what do you see? Yeah, but you've probably now had time to imagine like 10,000 different ways you can make this better. So what's one or two good ones going forward?
What we're seeing and thinking about is agent orchestration. Uh, there are many different ways of doing this. We've been looking into IBM's solutions, but we've also just looking at how we think the future will look in terms of AI agents talking to each other and such. So I have this diagram up here, which is how we imagine things will look. As you can see, there are many different entry points and things entering this diagram. You have humans, you have automations and different workflows. You also have loads of different agents with specialist sub-agents. The agents are talking to each other. One person here has its own agent, like ChatGPT, that's talking to these agents, might never actually visit our client's landing page. So these are things we're looking into.
What I took away when you first showed me this one is really a manifestation of the lesson learned before, where the tighter you get the input to an agent and the more specifically you've trained an agent to do a particular thing, the better the results are. Also, in a modular architecture like this, like you can debug one specialist agent without messing up what another one is doing. So I really see
Mhm.
those two things present in your diagram here. The one of them being specialized agents are are better agents, and modular architecture is easier to debug and maintain.
Yeah, it all goes back to this, the philosophy of trying to split tasks into smaller tasks.
Well, splendid. Um, so with that, I think we should go ahead and wrap. We'll call that, modular agent thing. Maybe we can name that one the Kulvik theorem. Although, to be honest, maybe we might be a little bit late to give it such a name
Yeah,
because
I
much of the
think so.
market is headed there. But anyway, Tobias, regardless of what we call the theorem, thank you very much for the work you're doing here, and thank you very much for joining us.
Yeah, thanks for having me, Chad.